This is the third example problem as part of our fluid pressure review for exam 4 and also for the final exam. And again, we're going to work this problem several different ways to show you, just to give you more tools in your toolbox and to give you confidence in the methods. So this is now a submerged gate. This is 10 foot deep. There's a gate here at a 3, 4, 5 slope. So 10 foot deep to B. And then this plate is 8 foot vertical and 6 foot horizontal. The fluid here is 65 pounds per cubic foot, so it's slightly heavier than fresh water. And so this has a specific gravity of 65 divided by 62.4, which is 1.04. If you were ever given a specific gravity of 1.04, then you would just multiply that times 62.4 to get gamma. We're going to find the resultant force on AB, and we're going to find the resultant force on BC. We're just flexing our muscles. On AB, we can use the pressure distribution. And so this is a triangle. The depth here is 10. The pressure here is 10 gamma. This is a free surface, so the pressure is 0. So we have a triangle. It's 7 feet into the board. Gamma is 65. So FR is 1/2 base times height times width. So 1/2 of 10 gamma times 10 times 7 is 22.75 kip, 22.75 thousandths of pounds. The second method is we'll use the gamma Z bar A formula. So this is a 10 foot deep plate. Z bar is 5 feet. The area is 10 times 7, which is 70 square feet. And of course, our gamma is 65. And so gamma is 65, Z bar is 5, 70 is the area, and we get FR is 22.75 kip. Very easy, very straightforward. Remember though, FR does not act at Z bar. FR acts below that because of the triangular shape distribution. FR acts at a third of the way up, so 3.33 feet up from B. We're not going to use a horizontal and vertical on this because the horizontal is basically the same as what we just found. There is no vertical, or the vertical is 0. When we get to this lower plate down here, BC, so the pressure distribution is a trapezoid. The pressure at B is the depth, which is 10 times gamma. The pressure at C is the depth, which is 10 plus 8, which is 18. So this is 18 gamma. And this is a trapezoidal shaped distribution. And so FR is the volume of this pressure distribution. So the average of 10 gamma plus 18 gamma times L, which is 10 feet, times the width into the board, which is 7. And so we get 980 gamma, and FR is 63.7 kip. We can use the gamma Z bar A formula. So the Z bar is 10 plus half of 8, which is 4. So Z bar is 14 to the center of this plate. The area is 10 times 7, which is 70. Gamma is 65. So FR is 65 times 14 times 70, which is 980 gamma, which is 63.7 kip. Same as we got here. Pretty easy formula if you know what you're doing. You're always better off knowing what you're supposed to know, being good. It's better to be good than to be a fool. So finally, we can actually use horizontal and vertical here as well. So the horizontal on this plate is basically this trapezoid here. And this is 10 gamma here. This is 18 gamma. And now the height here is 8. It's not 10, it's 8. And so my F horizontal is 10 gamma plus 18 gamma divided by 2 times the length of this plate, which is 8, times the width into the board, which is 7. We get 784 gamma for F horizontal. and that's 51, basically kip horizontal. Our F vertical is the weight in this volume 1 plus the weight in volume 2. So the W1 is 10 times 6 times the depth, which is 7, times gamma, and that's 420 gamma is weight 1. Weight 2 is 1/2 of base, which is 6, height, which is 8, times the depth, which is 7, times gamma is 168 gamma. The sum of those two guys is 588 gamma. So my F vertical is 38.2 kip down. So you can write the FR as a vector, which is basically 51I minus 38.2J. And if you express this in polar form, you get FR is 63.7 kip, basically at a 3-4-5 slope. And so 63.7 is what we got up here and got up here. So again, multiple methods to work the same problem. And so just illustrating to you all of the different ways that you can work this problem. Now, a curved surface, you can't use the Gaza formula. The curved surface, you can't use the volume of the pressure distribution. So if it's a curved surface, you pretty much have to use the horizontal and vertical. Keep that in mind.